This was an example where we had a bad discharge transducer. This was actually one where when we were doing the diagnostics, we couldn't identify remotely any reason for there to be an alarm. We were getting the system was going off on compressor safety alarm, which was traced back to the high-low pressure switch. The high-low pressure switch, we were able to talk with a maintenance mechanic on site who was able to reset it. Well, we know when that trips, we either went above 1600 psi on the discharge, or we went down below 200 psi on the suction. And we're looking at things and we're like, we're never, here we're operating and then we trip. Well, I can't see off to the side, but I think we were like 1300 psi. We're well away from 1600. The condition was present. It was reset manually on site. We operate, everything was looking perfectly normal. And then all of a sudden, boom, we trip. Now we're off. Now things have equalized. Guy goes out, resets it again. Everything's running normal. Boom, it trips again for no particular reason. I mean, we're looking at discharge temp. We're looking at chilled water sensor. We're looking at suction gas temp. So then, that's where we make the call. Okay, well, I got to get out on site. And when I say I don't mean I personally, I mean, as the mechanic, as the technician that services the equipment, go out on site, see if these pressures are right. Is this making sense? And in this case, we were actually getting up to 1500, 1600 psi, but there was a faulty discharge pressure sensor. It just wasn't reading accurately. So that you can verify that. That's when you make that call to get on site. But the remote diagnostics kind of already pointed the direction. Like, hey, we're going off on high pressure, low pressure. Let's make sure those pressure transducers are reading accurately. So on-site time was 20 minutes, super quick to get it identified.